Hello everyone, today we are covering a topic from IGCSE Cambridge Physics, lesson Motion, Forces and Energy, topic Motion, and subtopic Speed and Velocity. First, I want you to think, is speed and velocity the same thing? Although they seem very similar, they're not at all the same. Let's first look at why they're different. Say you're going from home to school. There's no straight line path cut out from home to school, right? So you might need to take turns, pass some roundabouts, and even take some detours to avoid the traffic. And this length of the path you traveled is called distance. You recall what displacement is? Displacement is the shortest straight line path from your initial position, in this case, home, to your final position, in this case, school. This is your displacement. Now let's look at the most important thing, speed and velocity. Speed is the distance traveled per unit time, which means speed is associated with distance. Distance is a scalar quantity. So is speed. Which means both distance and speed, they only have a magnitude and no direction. Now let's see what velocity is. It is the change of displacement per unit time, which means velocity is associated with displacement. Displacement is a vector quantity. Therefore, velocity is also a vector quantity, which means both of them, they have both direction and magnitude. If we were to write these definitions as equations, speed will be expressed as average speed is equal to total distance divided by total time. Why average? Because say we're going to school, would you be traveling in the same speed throughout the entire journey? No, right? You will have to stop at traffic and then maybe go faster when the traffic clears up. So your speed is always changing. Here, we are only going to be finding a speed which is the average for that entire journey. Also, keep in mind, questions would not always ask for speed. They will ask for distance, having given speed and time. They will ask for time, having given distance and speed. So you have to know how to use the triangle method to come up with the rearranged equation to find whichever quantity they asked for. What about the units of speed? We can derive the units by using the equation, distance over time. Units of distance would be meters or even kilometers. Units of time would be seconds, minutes, or even hours. So the unit of speed would be meters per second, or even kilometers per hour, or even meters per minute. The most important thing is, on the numerator, we will have units of distance. And on the denominator, we will have units of time. Now let's look at velocity. Velocity is the displacement per unit time. So the equation would be average velocity is equal to displacement over change in time. You must be wondering what this triangle in front of these letters are. The triangle is the Greek letter capital delta. In science and math, we often use it to symbolize a change. So if you see delta in front of any physical quantity, it means the change of that physical quantity. For example, here, x alone means position. So delta x means change in position, which is the definition for displacement. And delta t here means change in time. Let's look at the units of velocity. Displacement is always given in units like meters, kilometers, and time is given in seconds, minutes, or hours. So just like for speed, the units of velocity can be meters per second, kilometers per hour, or even meters per minute. But remember, speed and velocity are two very different things. When we talk about motion, there's another important quantity, which is acceleration. Now, think about the time you're going to school again. We are not always going in the same speed, are we? So acceleration is a quantity that describes the change of velocity. So the definition for acceleration is rate of change of velocity. In this form of an equation, acceleration is equal to change in velocity over change in time, which means A is equal to delta V over delta T. For example, say you were traveling in a car at 20 meters per second when there was some traffic. Suddenly, the traffic clears up and now you accelerate to 50 meters per second. What is your initial velocity? You were initially going at 20 meters per second. So your initial velocity is 20 meters per second. What is your final velocity? You finally reached 50 meters per second. So your final velocity is 50 meters per second. Then what is your delta V? Delta V is the change of velocity, which means we have to take the final velocity minus the initial velocity. Final minus initial. So in this case, 50 minus 20. So delta V would be 30 meters per second. And now to get the acceleration, you have to simply divide it by the change in time. In a question, usually they would give the time. When we're talking about changing velocity or speed, it can either be increasing speed or even decreasing speed. Say you were traveling at 30 meters per second in a vehicle and you suddenly saw a cat crossing the road. So you hit the brakes and stopped the vehicle. What was your initial velocity? It is 30 meters per second, right? What's the final velocity? 0. Because when you hit the brakes and come to a stop, there's no movement, which means there's no velocity. Velocity is 0. So what is your delta V? Delta V, like I said, is always the final minus the initial. Final minus initial, which gives us 0 minus 30. So your delta V becomes negative 30. When a negative value is divided by a positive value, you will get a negative answer. Now, the definition of acceleration is delta V over delta T. Can delta T ever be a negative value? No, right? Nobody knows how to go back in time. So delta T, change in time, will always be positive. So when you have a delta V negative value, your acceleration will also be negative. Now, when you have a negative change in speed or negative change in velocity, that acceleration, which also becomes negative, is called deceleration. While acceleration is described as an increase or a positive change in velocity or speed, deceleration is described as a decrease or a negative change in speed or velocity. Just so you don't mix it up, acceleration is the common term for the rate of change of velocity. It can either be positive or negative. When it is positive, we still call it acceleration. But when it is negative, then we call it deceleration. This means velocity or speed is decreasing. What are the units of deceleration or acceleration? Delta V over delta T. The units of velocity is meters per second and units of time is second. So your units for acceleration or deceleration would be meters per square second. Now let's look at this example right here. A digger's speed changes from 9 meters per second to a speed of 2 meters per second in 1.5 seconds. Calculate the digger's acceleration. First, we'll extract the data. The initial speed u is 9 meters per second. The final speed v is 2 meters per second. The time taken, or delta t, is 1.5 seconds. What is the acceleration? The equation for acceleration is delta v over delta t. And we know delta v can be written as final velocity minus initial velocity. So acceleration is final velocity minus initial velocity divided by the time. 2 minus 9 divided by 1.5, which gives us -7 divided by 1.5. So our final answer becomes -4.7 meters per square second. We have gotten a negative answer for acceleration, which means the digger has a deceleration. Now that we have discussed the theory, we will look at a few questions from the quiz bank. This question reads, tunnel is 40 kilometers long. A bus takes 20 minutes to travel from one end of the tunnel to the other. What is the average speed of the bus? This is quite easy. Off the bat, you can understand because they're asking for the average speed. The equation we should use is average speed is equal to total distance over total time. Now, have they given us the total distance? Of course they have. The distance of the tunnel is 40 kilometers. Have they given us a total time? Yes, the bus takes 20 minutes to travel. So is it correct if we simply divide 40 by 20 to get the answer? Not really, because look at the units. The distance is given in kilometers, but the time is given in minutes. And your answers are not in kilometers per unit, kilometers per minute. It is given by kilometers per hour. So the first thing you must do is convert this 20 minutes into hours. How do you convert minutes to hours? You need to divide by 60. When you divide 20 by 60, you would get 1/3 hours. So the total distance is 40 kilometers and the total time is 1/3 hours. You can either simply take, because this is 1/40 divided by 1/3, you can write it as 40 multiplied by 3. Or you can plug this directly to the calculator just like this. You will get the answer 120 kilometers per hour. That's your answer. We'll look at one last question. Ron runs a 100-meter race in a straight line. The table shows how his speed changes within the time for the first 5 seconds of the race. Table is given. What is the average acceleration of the athlete between the time 2 seconds and 3 seconds? So they have given a very specific time interval. So only this part would concern us, between 2 to 3 seconds. What is the equation for acceleration? Acceleration is delta v over delta t. Delta v in this case is final velocity minus initial velocity. So at the final time they want, which is 3 seconds, the velocity, the speed is 5.7 meters per second. And at the initial velocity, at the time they want, which is 2 seconds, is 4.1. This we should divide by 3 minus 2. 5.7 minus 4.1 gives us 1.6. 3 minus 2 gives us 1. So our answer should be 1.6 meters per square second. Answer 2. With this, we have come to the end of this topic. Thank you very much.